Okay. All right. Well, I'm going to go ahead and get started here. As you can see, I have my set of slides up, and we'll start with introductions. My name is Gary Rawlinson. I'm an adjunct at Cabrillo. I've been teaching there since about 2001, so some number of years. And I've also been teaching Cisco for about the last 25 years. And this course was something that it was actually designed by me to help people prepare for the CCNA exam, hence the title. And hopefully you have some background in Cisco networking, but that's what we're going to find out shortly. So if we'd like to have each of you, you would turn on your video and show and unmute. Please go ahead, Roger, if you could go ahead and introduce yourself. Just give me a little bit of your background in Cisco and Cabrillo and so forth.
Well, actually, I emailed you before asking you about how fast the course is going to be.
Right.
I'm taking the Amazon cloud course, and there's another one I wanted to take, but it required a CCNA course. So I was looking around and I saw this
Okay.
class. I mean, okay, let me try. I've done a lot of programming stuff.
Mm-hmm.
And as far as touching the wires and all that stuff, mostly it's my home internet.
Okay.
That's why I was unsure whether I had enough knowledge, but I guess I'll find out.
Well, here's how we can proceed. Well, first of all, it sounds like your background is not what this course is designed for, just to let you know, because we're sort of looking to prepare people to take the exam. And in order to be ready to take the exam, you really would have had some Cisco courses, some experience with Cisco. But that doesn't mean that you can't attend this course, sit in this course, and learn as you go along. It will how would I put this? Because I've taught this course and the CCNA courses so many times, I'm fine going through and teaching them at a fundamental or introductory level. Often that's helpful for people, even that they've had background. And the reason why is because if they've taken, for example, if let's say you've taken CIS 81, 82, and 83, well, if you took those in order and you just finished 83, that meant you took CIS 81 a year ago, and it's probably pretty rusty. And how much of that actually, was absorbed is another question. So I like to get a feel for the class as a whole, and then determine a pacing that makes sense for the entire class. So I can't say yet whether this will be too fast or not for you. I would guess that you would still be able to get a lot out of the course from this. Now, what other course is it that you were thinking about taking that required a CCNA course?
There was at Mission College, there was Amazon Web Services.
Amazon, what services?
AWS. It's their cloud.
Oh, Amazon Web Services.
Yeah.
Amazon Web Services, and they wanted you to have some Cisco background.
Oh, they wanted the person to take one course, and I guess I didn't want to go into the Mission College twice a week. And I saw yours, and I mean, oh, it's all online. Maybe I can see.
Okay. Well, if they're requiring that you have a Cisco course, this will certainly satisfy that requirement.
Okay.
Okay, this will, because if they're only requiring that you have one Cisco course or CCNA course, we're covering 3 semesters worth. And by the time we do this, over a period of actually 3 months, and even though it sounds like that's a very condensed approach, the material that we're going to cover in these 3 months, I used to cover when I taught boot camps in 5 days. So
Okay.
that's when it's really compressed. This will not be so compressed that you can't actually almost treat it as an introductory course for your purposes.
Okay.
Okay, and that'll be, of course, your decision as we go along, whether you want to sign up for the, additional semesters and stay with the course. Thank you.
Goes
Are
well.
you at Cabrillo? So you're enrolled at Cabrillo otherwise as well? Or
No, I'm just,
this,
this, I don't know how it quite worked because there's no credit for this class.
right,
I did sign up as a regular student, but when
yeah,
it came time to pay for this class, I didn't have to pay.
right.
This is free.
Yeah, this is a special program that's been started, not the CCNA exam, but the non-credit courses are special programs that have been started so that you can provide, the state wants to provide these educational opportunities. And when the non-credit first came into being, I contacted them and suggested this course as one of their offerings, and they liked it. And so that's how this course came to be. There are a number of non-credit offerings. This isn't the only one.
Okay.
Okay.
Actually, I found it by accident on cbc.edu.
Oh, okay. That's interesting. Okay, thank you. I'll tell you more about this course in a bit. Georgiana, are you ready to give us an introduction?
Hi, Gary. Yes.
Hi, how are you?
So I also am a novice for CCNA. I've been watching a few videos for the last few months for A plus, CCNA, Linux plus. I have the books for CCNA from Cisco, and I have the books for CompTIA for Linux plus. And I'm trying to go on a different approach with the way I look for jobs. I was unemployed for 5 months. I found now a job, and it's possible I found two. And I'm going through the checks right now. And I was in technical support for, but not desktop support, but technical support. I was in technical support, application support for 14, 15 years.
Okay.
I worked for Google for 3 years and a half almost, and that contract ended back at the end of August of this year. So I'm trying to find a different approach on looking for jobs and on finding going on a career route, because I enrolled in Cabrillo. I'm a student at Cabrillo, so I enrolled in Java, Python, and Linux, and also there was an introductory course for computers and technology. Um, the, uh, the teacher is Rick Graziano, and so I
Yeah.
took that course too. And I'm just trying to find a route because it seems like I haven't defined a career even up to this age.
Okay.
And it's too hard to find a job. I mean, technical support, just random jobs is not really a career. So I would like to take A plus, CCNA, Linux plus, maybe Net plus,
Okay.
but I'm a novice for CCNA.
Okay. Well, thank you. Let me address a few things that you brought up there. First of all, what came to mind as you were talking, because you're looking for a job. There was a friend of mine who was working at actually was a produce company. They were hard to describe, nonprofit produce company, but she had an accounting background and she had a networking background. And so when she applied for the job to be their accountant, she also told them about her networking background, and they were thrilled because they were a small company. They couldn't really afford a full-time networking person, but they certainly could be could use someone who had her skill level. So this is something that I think, if I were, back at the beginning of trying to get out into a job environment, just about any job environment. I don't mean just networking, but if I was going into non-networking related jobs in companies, this background that you will get will be of value. This background that you get will be of value even in your home environment sometimes if you have to troubleshoot at home. So it can be very valuable if you go out to a company and you say, yes, I want to be, in charge of your accounting or your sales or whatever, but I also know how to fix networks. And that will be something that will often light them up because most companies cannot afford, small companies cannot afford to have their own IT department. Now, if you're going to a large company like Google, and you said, I have a networking background, they would probably value it. But for the most part, they have an IT department. They don't really want you messing with their network anyway. So they'd say, yeah, okay, but don't touch anything, because
Yeah.
we want to have the experts always touch anything. And that's fine. But in the smaller businesses, it can be a real plus. So I understand. The other thing about this environment, so I feel very, very fortunate that I discovered computer networking instruction as a career. And as I was moving into this career, it occurred to me, I could see that there was a real strong advantage to pursuing careers in the IT world, not just networking, but in the IT world, that you don't have in other careers. So for example, let's say you want to become a lawyer. You have to have somebody else give you the okay. Someone has to accept you to a law school. Someone has to say, yes, you can go take the bar. No one has to do that in the IT world. You can go get certifications up the kazoo. And in fact, if I were to put down all the certifications that I've had in my IT career, it would be a ton because I've taught Novell, I've taught Nokia, Microsoft, Cisco, and Juniper. So I've taught, 4 or 5 different technologies and company certifications. And in each of those companies, I've had multiple certifications. So I've probably, just off the top of my head, probably have 35 to 40 different certification exams that I've had to pass. But the thing that's really great is that I didn't have to get the okay from anybody to go and take those exams. All I had to do was study hard. And you do want to study hard because these exams are expensive. You don't want to be taking them over and over. But I study hard and then I can go take the exams. So I feel that this is sort of a more open field, more open career to get into. Whereas if you want to become a lawyer or a doctor, a veterinarian, a nurse, all these other things, you've got to jump through some hoops where other people can stop you from pursuing your education. Here, if you become an expert in networking or an IT expert, you will be valuable. Even if you don't have certifications, you'll be valuable. Even without that. I remember, for example, I was taking this Cisco class. I was ramping up. This is early when I was learning Cisco. I was sitting in a Cisco switching class. And the instructor was explaining something which we'll actually get into in this class. And he got done. And there's a person in the class that said, well, now, what do you charge an hour to, and he at that point wasn't even certified in certain areas that he would be able to practice in. And he said, what do you charge an hour to come out and fix our network? He says, I charge $300 an hour to come out and it was like, whoa, and they didn't even bat an eyelash. It was like, okay, come on out, So, but the reason why he could do that is because he was good at it. Certifications are nice, but you have to be good at it if you're going to make, strong dollars. And if you are really good at it, you can make good money. In fact, another example of this, I was teaching a class down in Mexico City I was teaching to the primary provider in Mexico. I was teaching to the IT department. It would be like teaching at Verizon here. You know, it was one of the primary network providers. And I was teaching something that was talking about DNS, and I started to talk about what a great career you could have if you were a DNS expert. And the guy who had put the class together sort of nudged me and he said, don't say anything. Our DNS expert is here. We don't want him to leave and go make more money. It's like, oh, okay, I better not just show you how, tell him about how much money you can make just being a DNS expert. So I mean, what I'm saying is I encourage you to explore and find an area that you enjoy in the world of IT, networking, whichever you prefer. And then it's a matter of you can, whatever your initiative is, you can go ahead and ramp up and teach yourself a ton of stuff. There's a lot you can learn on your own. So anyway, so don't worry about it. It sounds like you and Roger are very similarly situated insofar as your background right now. Okay?
Yeah.
That's fine. Okay, well, thank you, Georgiana.
Thanks.
Armando, if you could go ahead and come on there and hello.
Hello, can you see me?
Yes, how are you doing?
Getting yourself?
Good, thank you.
Okay, so no introduction. My name's Armando, and I'm currently going for the computer networking and system administration degree or the
Okay.
associate in science. Uh, I retook CIS 81, 82, and 83,
Okay.
but I'm looking to take this course in order to prepare for my the CCNA.
Okay.
Yeah.
So this course is designed for you specifically, actually.
Okay.
Okay. I said for all people plus Armando when I designed this course. And but as you can tell, we have some people that are beginners.
Okay.
And what I'll try and do is as we go through, when you have questions, you want clarification, I will go ahead and answer yours directly. And if we lose them at that time for that explanation, that's going to be just the way it goes.
Okay.
So you can ask questions at whatever level you want. And
Well, I kind of need a refresher too, because I took them like a year ago, I
yeah,
think.
no
So,
problem. So I'm
so
going to
maybe
take the,
it'll help.
we'll move through this course at whatever pace works for everybody, and you know, adjust as we go along.
Yeah.
Now, what I want to say about how I teach is that as I am teaching things, sometimes I will flip over to a whiteboard. When I have taught these courses, so let me give you my background. 25 years ago, I started teaching CCNA classes. And at that point, we had slides. I was teaching for authorized Cisco companies. Actually, the companies that I was teaching with were not Cisco, but they were authorized by Cisco to provide IT training. And what I preferred to do was to teach using the whiteboard rather than slides, but we were required to present all the slides because it was a Cisco authorized course. So I ended up using sort of a combination of slides and whiteboard. I prefer the whiteboard because I'm able to develop concepts, develop items more incrementally. I think it's a better way of teaching. So as we go through slides here, to me, there's a ton of slides that have way too much information, or it's not presented in an orderly way. My point is this: simply ask at any time, ask any question. There's no question that is going to be too dumb. If you've asked me something that I feel, you know, would not be worth the class's time, very, very unlikely that you would, but I can always just take it up with you privately in an office hours or something like that. So, but do not hesitate to ask questions. And the reason why I say that is if you're sitting there and I've said something, it's not clear to you, and you don't say anything, then I think everybody is okay with what I've said so far. and I keep going. And that means you're going to fall further behind. You sort of, when you're learning networking, you're learning basic things and you build on those. And because you build on basic concepts, you're able to absorb more and more complexity as you get into it. But if you jump right to the complex or the difficult parts, you'll be totally lost. So don't hesitate to stop me and have me repeat or try different approaches, different explanations, go to whiteboard, etc. for anything that you don't understand. Now, there are some things that presented in this course that I think are fairly fundamental, that maybe not even bother with unless you're about to take the exam, and then there'll be things that you'll want to just go back and review just before you take the exam, just your final exam prep. Okay.
For sure.
All right.
Thank
So
you.
let's go through next the CCNA exam overview, and that's my next slide over here. So if you were to go online, you would see that this right here, all that I'm highlighting, these are the larger topic areas of what's covered in the CCNA exam. This doesn't do you much good, really. It's just such a high-level overview that it sort of gives you some parameters, but other than that, you're really best to understand what's going to be in the exam by going through the details, and you'll see that. Now, if you're going to take the exam, I would suggest you look at this slide or this little presentation here before you take it. It just gives you some heads up as far as what's going to happen when you're taking the exam. Do you have one choice or two choices? Can you go back, et cetera, et cetera? Just some exam taking tips. For now, I wouldn't suggest any of you bother to go through that. Now, again, if you're going to take the Cisco exam itself, when you get in there, time management will be an important part. The exam costs $300 to take. And because it's $300 to take an exam, you don't want to take it twice. So you're going to want to manage your time. And that means don't dawdle on some question that you're not too sure about. Don't spend a lot of time on it. I think you have 90 minutes to complete the exam. Learn how to take your best guess and move forward. Okay, that'll be important. As you get close to taking the exam, if, for example, Armando, if you are near the end of this course getting ready, if you think you're coming close to that, then we can circle back and talk about time management and question approaches. Okay. So there are actually 3 courses I put together in order to do this, because we're covering 3 semesters in the community college program. It really would have been just too much to try and compress that into 1 course, or even really 2 courses, though I've got this laid out to where we can cover most of the material in 2 courses. Each of these is 4 weeks there, 4 weeks here. But this covers, these 2 courses here cover all of the CIS 81, 82, and 83 material. Then I put together a 3rd module, a 3rd course, the 3, and this will be 483C, I think it is. And in this, we'll work with a lab scenario, and it's very valuable because it's so much hands-on. All this theoretical stuff that we have talked about comes together, and then you actually make it happen. And Georgiana, for you going out to apply for a job, you actually could take this scenario that I will present to you later in the course. You would take this scenario and after you've learned how to configure it entirely, okay? And seriously, if you know how to configure it entirely, you really understand the networking that's going on. If you were to present that to an employer and say, I can make this work, that's going to be very valuable. It'd be like presenting, a multi-page resume of all the things that you know how to do in one little scenario. So, at that point, the course will be much more hands-on, though to the extent we need to still be talking about any remaining modules, theory, etc., that's fine. But that part of the course uses a very complex scenario. But when you break it down and you do it piece by piece, then it both brings home the knowledge that you've learned, and you'll get a lot of you'll get a lot of self-confidence out of seeing what you can do. And I can tell you, when I first put that scenario together, I did so for a capstone course for Cabrillo way back, about 15 years ago. I created a capstone course for Cabrillo, and I used that scenario. And in building this scenario, I found it very encouraging to see, well, wow, all the stuff that I know how to do and make work in the Cisco environment. So that will be what will happen in primarily in the third course, though we may get to some of it beforehand and do parts of it as we go along. Okay. So the way that I will handle, and tonight will be primarily just a lecture, but what we'll do in class is primarily lecture and then some labs. And then we will also do some, we can do some practice questions. That can help a little bit. Not so much at first as it will later on. And then on the labs, they'll be on the Cisco Packet Tracer. Now, I sent out an email and I suggested you download Cisco Packet Tracer. Armando, you've used it before. But Georgiana and Roger, I highly recommend you download it and at least get ready to use it. We'll be using it before too long, and you'll find it very, very helpful. It's one of the most valuable learning tools out there that I can imagine. It's incredible. I could not overstate how valuable it will be to your learning. When I first started to learn Cisco, didn't exist. This packet tracer program did not exist. And I had to go out, I had to borrow a router. I could borrow one router from a friend of mine. And with that one router, I put together some connections and I built a little network in my home. And I was able to do some things. And I actually was able to learn quite a bit. But if I'd had Packet Tracer, man, I would have just been to the moon, because you can learn tons and tons of stuff. We'll get into it. I will show you all about it eventually. Okay. So we will get into, we're not going to do this today for right now, because I think that that's going to be a little ahead of us. I will get into Packet Tracer. I will probably start with Thursday. We'll get into Packet Tracer. So if you could all have it loaded up, sometimes I'll want you to follow along with me. It's much better if you are manually entering keystrokes when I'm giving you directions than you watching me enter keystrokes. It happens to be one of the few things I learned in college, okay? That you doing something interactively is much more value than somebody actually showing you on their own, because there's not that connection. If you ever, I don't know if you have ever played any sports, any of you, but if you ever see somebody out on the tennis court or out at the driving range in golf, and they've got a hold of the person while they're holding onto the club or the tennis racket, and they're making their hands do this, but the person who has the racket isn't actually making it, they're just following it. The person with the racket is learning nothing, because there's no motor sensory feedback going on. They're not building muscle memory that way. It's almost useless and probably could even be counterproductive. The same thing is true with networking. When you are sitting there and you're typing in commands and you see results, you see errors, then you will be getting a different type of feedback than if you simply watch me do it. Watching me do it will, besides, put you to sleep, will not be of much value in learning it. Okay? All right. I'm going to go ahead. Now we're going to take, usually we take a break about every 45 to 50 minutes for 10 to 15 minutes. What I'm going to do is switch over to module 1, and go up here to beginning of that. Okay, so where did I get these slides? The first set I built myself, but these slides are slides that are available in the Cisco Networking Academy course. Now, you've all been enrolled in the course and you got the email. Anybody have any questions about that at this point? Okay, so what it means is you can log in with your username, go in, and you can go through all of these slides. There's practice exams and labs, etc. You can do this on your own. So there's a tremendous, huge amount of resources, excuse me, that are available to you. And rather than assign a book that you'd have to pay for, I am letting you have access through, actually, I would say, Rick Graziani. I think, Giorgiani, you said you're taking a class from Rick.
Yeah, I took in spring 2023.
Okay, so he is one of the head instructors. He is the head instructor there at Cabrillo for networking. And it's working in cooperation with him that he has okayed for me to use the Networking Academy materials. So these are the materials you would use if you took CIS 81, 82, and 83. You're getting access to the same materials and to the same resources, packet tracer, and so forth. Okay? So I encourage you to go in there. Now, if you are new to networking, I can tell you that networking is difficult. Now, when I say it's difficult, what I mean is there's a lot to it, so it takes a bit of time to study it. As far as any one concept, the concepts themselves individually are simple. They're basically simple concepts. You'll find that out. But there's so many of them that it's very easy to overload somebody. So what I'm saying is two things. First of all, yes, learning networking involves a lot of work because it's quite a task, but it's not learning things that you won't be able to understand. The problem that you will have, and the thing that's kept me actually in business, okay, the reason why I'm still an instructor after 25 years is because there aren't any materials written out there that are written well enough to teach people. It really comes down to it. Most materials that are presented are not written well for teaching. They're not inaccurate, they're accurate, but they're just not written well for teaching. And they try and present too much, or they're not specific enough, etc. So anyway, so now we're going to go through these networking today. So this is just general stuff, and a lot of it won't even be news to you. But the first thing you want to understand in the world of networking is that what we are doing as people that are trying to configure networks is we are trying to enable communication from a client to a server generally. That's usually the environment. So what is a client? A client is a device, often a computer, most often a computer, that is requesting something from a server, information, some type of search service, but usually it's information or files, things like that, or a printing service. So servers provide services, clients request those services. For example, let's say that I'm in a large corporation and I want to print a lot of papers. Do they want to give every one of the users in a corporation their own printer? No. What they want to do is have a printer attached to the server, and then whenever I want to print, I send my job over to the server, and then the server sends it to the printer. Okay? So that at that point, the server is providing print services. I have files that I'm working on. Do they want me to store all my files here? Not really. They'd like to have me store the files over here. There's a few reasons why. One is just space efficiency, but another reason why files should be stored over here is then they can be secured better and they can be backed up. Secured meaning that they can have permission set so that not anybody can get to them. And backed up, of course, means that they're copied somewhere else so that if this server falls apart, that they can be restored. So servers are a big part of a company's operation. When we are configuring the network, though, we're configuring most of the infrastructure in here, in between these two. Essentially, you might say, this is the home, this is the business you're going to, all that pavement that you drive over and all the cars and everything, we're concerned with making all the infrastructure in here work. Okay, that's what networking is about, the infrastructure to enable communication from a client to a server and from a server back to a client. And we have here 3 examples of services that a server might provide. So a server might have an email service. In other words, we can store emails there and have them delivered to us and send them through. Web, it is housing a website, and we can then download information from the website and even upload information to the website, and then just can store files. Those are just 3 examples. And clients are requesting. So that's the thing. Clients request services. Servers provide services. Okay? Very important distinction that we want to have as we go through. All right. Now, you'll see this term peer-to-peer. What this means is that you have some computer out there that is acting both as a client and a server. And the Microsoft client software, all of you have probably either Windows or you have Apple, right? On your your computers at home. That software enables your computer to act as a client or a server. And if you have, let's say I have 2 laptops at home and they're talking to each other, that's peer-to-peer networking. That's what it's called, okay? Let's not worry anymore about that, but that will make sense as you end up doing that now and then. Okay, so the end devices are generally part of a network, and that will be generally part of what's called a local area network, LAN, local area network. And we have end devices over here in another local area network. And to get from one to the other, they have to go through the internetwork, sort of like going through an interstate highway. And our job is to make either this or this or this work. Generally, if you're a network administrator, you'll be working on the LANs. But if you're working for a provider, like if you're working for Verizon, then you're making the internet work. Okay. In making all of this internet work, we have all these different devices. The 2 most common are routers and switches. Okay, so we'll learn how they operate. Once you understand the OSI model, TCP/IP model, you understand how to associate those with different levels and layers of the models. Then we have wireless router, which is basically just a router that is not using a physical connection, but a wireless connection. And we won't worry about these for now, okay? Media is how we get information from one place to another. We generally don't use 2 tin cans and a string. So what we use, maybe metal wires in cables, or glass or plastic fibers in cables, or wireless. You folks have done well, you probably have done all this, but I know you've all done wireless. Every time you get on your telephone, you're using wireless. And on your computer, if you go to an office, it might be wired. Okay. When we diagram our network, we have what are called topology diagrams. A topology diagram And within that topology diagram, we have symbols to represent devices, okay? So here are symbols. We have this symbol representing a computer or laptop, printer, phone, etc. Here we have the intermediary devices, wireless router, LAN switch. You see a LAN switch is a square, router is more of a circle. So that you'll see when I am writing things on a whiteboard, routers are circles, switches are squares, and we'll understand the difference between those eventually. Okay. For right now, don't worry too much about these semantical distinctions, but Armando, of course, you will want to bone up on these before you take the exam. So we have a physical topology, just as basically is where all the devices are. Physical topology is physically where they are. Okay, we've got a switch here, we have a router there, we have a switch here, da da da. A logical topology has information about addressing. In other words, yes, we have a cable from there to there, but what we want to know is what is the network address that goes with it. And so this is letting us know how our network is laid out as far as addressing. That's called the logical topology. Okay, physical topology is where the devices are. Logical topology is how the network is addressed. Okay. Again, they're coming from an introductory point. This is all very basic stuff so far. So as far as networks, of course, you all have you're all on a small home network right now. Okay. And you have a connection to the internet, probably through a router that is in your house. I say probably, it doesn't have to be, but you probably have a router that provided by a provider. You probably have Cruise.io or Xfinity if you're there in Santa Cruz, and you have a router, and you are connected to that router either wirelessly or wired, and that's your own small home network. Small home, a small office, home office simply means, again, you're just doing business out of your home. That's all it is. We have many, many businesses out there that would fall into the medium and large. That's, most businesses in the world. And then we have worldwide networks. And of course, those are made up sometimes of multiple connections between branches and headquarters of large businesses. Okay. So just some terms that you would want to know for the exam. Okay. So now again, LAN and WAN, local area network, wide area network, two fairly simple concepts. Your home office is a LAN. A branch office is a LAN. The central headquarters is a LAN. Those are all local area networks. And what we have to connect them is a WAN, wide area network. And we'll see that the protocols and the technologies that are used here are different than are used here. Okay, so LAN, we're going to interconnect devices in a limited area. Okay, so how limited, that really, it's very hard to say, but basically, you could have multiple LANs in a, let's say a business. For example, the Cisco campus is made up of multiple LANs. It's not one LAN, it's multiple small LANs all interconnected together. Now, they're not interconnected together through a WAN, they're just interconnected through the backbone structure in their environment. The WAN would be, of course, those connections that they have out to the internet that would go to another campus or another headquarters or another branch. Okay, everybody knows what the internet is, and we're not going to go through all these different organizations. Armando, you will want to review this just before you take the exam, because these are the type of things you want to make sure you have on ready for the day of the exam, and the day after you can sort of flush that out of your mind and make space for other stuff that you'll need, okay? Okay, we have another concept and some semantics here. We have the internet, they're putting it out in this way, the internet, for some reason they want to do it this way. We have an extranet, okay? An extranet means a network that is outside of your business, but might be so for example, let's say that your business is selling a certain item and you have a supplier. And so what you can do is, let's say you can connect to the supplier and go into their network and put in an order for more items for your business. That would be their network is to you an extra network. To them, their network is an intra network within the company only. Okay. So these will become more familiar, but they're just sort of relative locations of where things are. Okay. You want to know eventually, for test purposes, these different types of connections and more detail about them. But for right now, we're just wanting you to know that to get to the internet, there are many ways to get to the internet. You all are probably familiar with at least two of them, because you have a cell phone that's cell-based, and you have your laptop, which is probably based off of wireless. And those are two different types of wireless technology. So you have something in there in your house. So in your house, you're like a home user. For you to get out to the internet, you might have DSL, you might have cell, you might have dial-up telephone, you might have cable or satellite. So one of these you're using at your home to get out to your provider. Most of you are probably either using DSL cable or cellular, probably not using satellite or dial-up telephone. Are any of you using satellite that you know of? I wouldn't think any of you are using satellite. You don't have a satellite connection. Okay. So, for example, I have a little hotspot, it's about that big, okay? Small, it fits in the palm of my hand, a little hotspot. And that will act as a mobile router, and it is cellular based. Cellular based means that it's making connections to cell towers in order to communicate and put me on the internet. My home here, where I am now, has a cable connection through a TV provider. So I've got Spectrum TV, and I have a cable that goes from me to the Spectrum central or local office. So that's a different way for me to get on the network. A friend of mine is out in the Aptos area, and because of where he is, I think he's using AT&T, might still be using Cruise.io, but he has DSL to get to the internet, or to get actually to the Cruise.io office. This you just don't want to use. But if you absolutely have to, there are situations where that will work. Okay. Corporate businesses are generally going to have something like a dedicated lease line or Metro Ethernet, business DSL, or satellite, something like that. It depends upon what the business can afford and what they need. But we can see that they're in a little different arena there. Okay, now let's talk about the converged network. The converged network is something that you folks are probably taking for granted. It's like, what do you mean converged network? What did it used to be? Well, there was a long time ago, right after there were covered wagons, we had phones that would hang on the wall. Okay? And there was a dedicated line from your house to the local office, to the local phone company office. That line only carried telephone traffic, voice calls, and they were analog calls. When computers came along, at some point, we started to run voice calls over digital networks. Now, is everybody familiar with the distinction between digital and analog? You should understand the difference between digital and analog, okay? So that phone that was hanging on the wall, when I talked into that, there was a wire that was essentially, you could say, through the telephone company connections, there was a wire that directly connected me to the other end. Just like if you're sitting there with two tin cans and a string between two people, right? Except it was a long, long connection. What was going on over that is analog. The actual voice signals were being carried by the wire. When you digitize that, what you do is you take samples. How many of you are familiar with sampling, digital sampling? Okay, a little bit, no. Okay, so all right. So, okay, I'll just explain it rather than flip over to a whiteboard. We can get back to this on a whiteboard. It's a little bit easier to demonstrate. But right now, as I'm talking to you, my voice is emitting these signals, okay? Well, the signals themselves are not being transmitted to you. What's happening is my computer is actually taking the signal and plotting the signal by way of taking a sample of the signal at each point as it moves along in time. So, and it converts that plot to I'm sorry, not to 1 or 0. It converts it to a position by way of describes that position on the XY axis as a combination of ones and zeros, okay? So what is actually going from my environment here, not from me to the computer, but from the computer on out, what's going on out are little packets of ones and zeros. And they represent the signal that's being generated by my voice. When those little packets get to your end and get to your computer translates those back into an actual analog signal. So you get an analog signal, but what took place across the wire was a digital signaling, you might say, or packetizing of the analog signal, okay? So to circle back, it used to be the phone was on the wall. I had one network out there, a telephone network, just to transmit telephone calls. And we'd have a separate network for data. Now it's all converging into one network. And what's happening is that data and voice and music and video, all these are going over one network. But there was a time, not back, you can still find this, but for the most part, there was a time when if I wanted television in my home, I would have the cable company bring out a television cable. So that's a wire to carry all of the television information. I would have another set of wires that were connected to my home to carry my phone conversations. That was called a landline. So I would have, at that point, two different networks to carry the two different things. One to carry television information, one to carry telephone information, okay? Now those two have converged and all of it can take place over a single network. And that poses challenges for us as network administrators, but of course it also has a big advantage of reducing the physical infrastructure that's necessary to accomplish this communication. Okay. So now what we have going across a single environment is data, voice, and video, etc. All right. How are you folks doing? Do you need a break now? Would you like to take 10 minutes now, or do you want to go on one more module or one more little chapter here? How are you guys doing? I haven't put anybody into a little coma yet. Okay, let's just go on a little bit more and then we'll take a longer break. Okay, so reliable networks. And again, we're in the introductory phase of this course and of this Cisco presentation. What we want is a reliable network to provide various you might say capabilities. So let's look at what these various capabilities are, these 4 capabilities. So whatever our network architecture is, we want to make sure that it provides fault tolerance, scalability, security, and quality of service. So we'll look at what that means. So what is fault tolerance? Okay, well, I would not pay too much attention to exactly what they're saying here. It's a little bit actually incorrectly stated. But essentially, if we look at this up here, what we see is we have, for us to get to the internet from this environment here, we go up to that one router, but from there we could go that way or we could go that way. So what we have are what is called redundancy. We have 2 different routers that we could go through, and if this one failed, we could simply have our packets routed out that way. That's called fault tolerance. Fault tolerance is basically the ability of the network to absorb some level of failure. Now, if I'm on my machine here and I'm connected to that switch, and that switch cable fails, there probably is not going to be any fault tolerance. At that point, I'm no longer able to get out there. But once I'm at that switch, we could have multiple links that we're just showing one link, but there could be a link from here over to there. And then from that switch, if this link went down, we could take another route. So we have multiple paths that could be taken. And you might say an example of fault tolerance in, California would be, let's say that you want to go from LA to San Francisco. You have 2 routes. You could go up Highway 5. You actually have more than 2, but let's say you could go up Highway 5, or you could go up Highway 101. Well, has Highway 5 ever flooded, or Highway 101 flooded? Yes, they have. So if one was flooded, you could then go the other route. So you'd say that within the state, our infrastructure has some level of fault tolerance. We won't talk about all the traffic jams you'd encounter if one was shut down completely, but you get the idea. There are multiple routes, multiple ways to get there. And so if something fails, it doesn't mean that we're shut down completely. That's fault tolerance, the ability to withstand failure. Okay, scalability. Scalability means the ability to expand, right there, expand our network, okay? So what you see is sort of an environment here, a topology, where you have a number of workstations and phones, et cetera, connected to a switch that go up to a router, okay? And then that router has multiple ways to get out to the internet. Well, this could all be one building. Well, let's say I have another building. Well, I just repeat this, I duplicate it, and I go over to another building. I do the same thing, and that has one link up. And I go over here and I do it again. So what we're saying is that we can keep adding to this network, but not overloading the network, because in this case, we have only traffic over that one link coming from here. We don't have the traffic from here and here going over that one link. Now, of course, going up this way, we might want to be able to take advantage of, and there's technology that allows us to do this, have traffic that comes here and comes there, be able to use both that link and that link, okay? But the point is of scalability is that we have a structure here that we can just repeat over and over and over and build our network out. That makes it scalable, okay? And you'll see that that's part of actually the design. The network designers follow both standards and protocols, and they are able to expand the network without losing performance. Another aspect of a reliable network is something called quality of service. And quality of service can best be demonstrated by this. We understand that we now have a converged network. So we're using the same network to download data. For example, let's say that let's say I'm uploading pictures to to a server in the cloud, okay? and I've got these large pictures that I'm uploading to a server in the cloud. And I'm also watching a video. Actually, let's do it this way, so we're both going all the same direction. I'm downloading large pictures from a server on the cloud, and at the same time, I'm also watching a video, okay? Now, as those files are being downloaded to the network, what do I expect to happen? I expect there's going to be delays and it's going to take a while, right? I'm not sitting there on the edge of my seat watching every byte of download come into my computer on those files. So let's say that I've got 10 huge files of pictures that I'm downloading to my computer, okay? If it takes 10 minutes to download that, or it takes 12 minutes to download it, do you think it's going to bother me that much if it takes 2 more minutes to download all those huge pictures? No, I'm probably not going to even notice the difference. It's just like, yeah, it's still downloading. Okay, I'll go get another, glass of water, or have another glass of have another beer or something, whatever I'm going to do. Go get some more chips and sit back down and watch the game. It doesn't bother me at all that in fact it's taking more time. And if let's say that a lot of people start downloading those pictures and it gets even slower. Yeah, it's a little bit annoying, but it really isn't going to affect it if eventually, within a reasonable time, I get those pictures on my computer. But let's say I'm watching a streaming service, I'm watching a movie, and a lot of people are watching a movie. And all of a sudden, what I get is a little bit of the movie, it stops, a little bit of the movie, it stops, a little bit of the movie, it stops. Now, I'm getting very small delays, but it's really annoying. And if I was having a phone conversation and every other word, there was a pause or a stop, or it had to be resent, it'd get really annoying. So what we do by way of configuring our network, and this is not something you will have to learn how to do at this level, you just want to understand the concept, is that as packets come into a router to be forwarded on down the road, on down the network infrastructure, the router can prioritize certain packets over others. So the router can say, oh, okay, that's video, that needs to go right through. That's part of a large file. We can hold that for a little bit, make sure that everything else, all the video gets through before we put that file on there, okay? So I'm trying to think of what would be an example, but I think you probably get the idea. Basically, what you're trying to do is you're trying to set up a priority of packet forwarding so that the quality of service to the end user is acceptable. For this level, at CCNA level, we do not learn how to actually configure that. That's at the professional CCNP level, how to configure quality of service. We just have to understand the concept that some traffic is more important than others, and the devices can be configured to push through the more important traffic more quickly, okay? It would be like a cop standing in an intersection where things are a lot of congestion, right? Cops in the middle of intersection. He sees an ambulance approach. That ambulance is going to get top priority, right? And especially if you're in that ambulance, you want to get top priority, right? So that's what a router can do. It says, here comes something really important. It goes right through. That's quality of service. And then the last thing is network security, which of course you're all familiar with. You have firewalls that you are probably communicating through. You have security concerns in your environment. You probably have, well, I'm sure you do. You have tons of passwords to protect your access to different things. You don't let, like if you have friends over, you don't let your friends play on your computer that has all your important homework assignments and your email and whatever else you have on it that is important to you. And so you have different types of security, and security can be very basic. For example, it could be, I've got my laptop here. The one thing I'm not going to do is let somebody come in with a whole lot of drinks and set them down on top of my laptop. Okay, right? If the dog's running around, I'm going to make sure the dog can't jump up, knock my laptop onto the floor, and wipe out my laptop. That's physical security things. If you've got kids, you don't let your 3-year-old kid have access to your business laptop, right? So that's just a security measure. So network security encompasses many things: physical security of the devices, preventing unauthorized access, and protecting the information. So for example, when you send something that is of a sensitive nature, you might encrypt it so that anybody that did intercept it couldn't figure out what is in there. So there would be encryption involved in certain of information to protect it. Okay, well, let's pause here and let's take about a 15-minute break to 7:25. We'll come back and pick up here and then go on. And we'll probably go to just a little bit before 9 o'clock tonight, probably about 8:45, 9 o'clock. Okay, I'll see you back in 10 minutes and 15 minutes, I mean. Okay, we'll go ahead and resume here. Again, this is all very introductory. We're not looking at anything too hardly technical at all yet. So things have changed over the years, and they're just pointing out some of the trends that you would encounter out there. Bring your own device, of course, means that people are showing up at work with their own cell phones primarily. Sometimes their own, pads, sometimes their own laptops. But, the biggest of those is everybody's cell phone, which is a computer, basically. There's also a lot of online collaboration that takes place by way of meetings and things like that. There are a lot of video communications, of course, that would be sort of in that category as well. And then cloud computing. And here's just something that we all would know about. And again, we've all done that. We're doing this now, online collaboration. So we certainly understand it. And video calls like we're making right now, very powerful and revolutionary in a sense. You can now have a phone call, video call, without even having to sit there and hold the phone against your head or any of that. We don't have to have local storage. That's also can be very valuable if you trust cloud computing. It sort of takes away your concerns with local storage. And different types of clouds. We won't worry about those right now. Again, you can review this stuff, but for our purposes, it's not essential. Okay, and so we, again, more of the, what we would expect. Home technology is becoming smarter, et cetera, nothing new there. Power line networking, if you get into this, you'll want to understand it a little bit better, but it's simply a matter of being able to take advantage of existing infrastructure, such as power lines, to then send data, not just power. And of course, wireless broadband, the distinction between broadband and baseband is eventually one that you'll understand, but basically broadband carries multiple signals. So that means that a cell tower is sending out signals for multiple people. It's not just you and the cell tower having a dedicated connection. So there's all sorts of signals being sent out. And another example of broadband would be the cable coming to your TV is carrying signals for all the different channels in that one cable. And so when you flip from one channel to another, you're actually just picking up an existing signal. You're not causing a different signal to be transmitted from the provider. We will cover security to a degree in this course. It's sort of for the most part, a higher level security, but we'll want to understand the different types of threats and how we counteract those threats, either how we would do so on the router, on the switch, or on other devices such as firewalls or laptops that have firewalls and so forth. And we'll go through all this. They're just sort of running through some things now, but we will actually have a chapter on security threats. And we'll also have a chapter on, so we won't get into it now right now, but we have a chapter on solutions, all the different things. We'll understand what we do on a router to secure the router, and also what can be done across the network itself. Okay, so that takes us through the first module. I'm going to go ahead and actually, I'll leave that. I'm just going to flip over to module 2, and hopefully that worked. Now, for tonight, I'm going to sort of breeze through this a little bit, but what's going to be best, and we'll take this up on Thursday, is we're going to want to open up in Packet Tracer a command line so that we can configure the switch, and I can demonstrate different configuration capabilities and options to you. So we'll be going through this, but let me tell you this about the command line and Cisco commands. There's a ton of Cisco commands. Nobody knows all of the Cisco commands, as far as I know. No one does. No one wants to. And you will most likely also never know all of the Cisco commands. So what you end up wanting to do is learn how to issue the basic commands, the core commands that you would use day to day, and then learn how to figure out the other commands as you go along. But you're going to be learning the basic, how do I manipulate the Cisco router or switch? How do I configure it? And there are a number of steps that you'll learn how to take. And it at first seems a bit daunting. It's a little, it's not intuitive. I remember I've taught the command line at some of my boot camps. And then I would mention, oh, of course, there is a GUI. And they go, there's a GUI. What do you mean there's a GUI? Why did we learn all this stuff? Well, Cisco wants you to know how to use the CLI, command line interface. They want you to know the commands. That is how most administrators configure devices. They sit down and they issue commands. In some cases, you'll use a GUI, but for the most part, you're issuing commands. And that's just the way that Cisco set it up. It's actually the same thing in Juniper. If you're familiar with Juniper, is like Cisco, a company that produces routers, switches, and firewalls. And they also have a command line interface. They do a little bit different approach, which is, I think, a bit more elegant. When I taught Juniper for about three or 4 years, and I really liked the interface. At first, it seemed really like, what's going on here? This is so crazy, because I'd come from Cisco and it seems straightforward. But then after I got to understand the Juniper approach and the way that they did it, it was actually much more elegant. And when I circled back to Cisco, my feeling was, well, this is sort of primitive. Why are they doing it this way? But it's fine for us. We'll learn the Cisco interface. And if you end up out there wanting to learn other devices, and that's something that you can consider, is you learn Cisco stuff because it's networking basics. That's what we're learning, is networking basics and how to implement those basics with a Cisco device. But when you then want to go learn, for example, Juniper networking, you've already got to step up. You understand so much of what you're trying to do. It's just a matter of learning how the command line interface is a little different. So let's look at this. Cisco iOS Access. So iOS is Internetworking Operating System, and Access is how are we going to interact with this operating system? Okay, that's really what it comes down to. So what we're going to be doing is we'll be using a shell, and that's our interface. That's what's presented to us is the shell. The shell will be either a CLI or a GUI interface. And through that, we will communicate with the kernel, which is the actual operating system. And the operating system, of course, communicates with the hardware and makes things actually happen. So that's what we're going to do. We're going to learn how to use the shell. There are multiple ways to interact with the device, routers or switches. One way is through a direct physical connection that goes from your laptop or computer to the router or switch. And that would go into what's called the console port. So there is an actual management port that you can connect to directly, and then you connect it to either a USB or a serial interface on your laptop or computer, and you bring up a program that allows you to then be in the shell, and away you go. You are now connected to the iOS. And you might think of it this way. When you buy your computer or laptop, what you get is a computer plus a keyboard plus a monitor. When you buy a Cisco router or switch, you get a computer. Router and switches are computers, just like your laptops are computers. But they don't come with monitors and they don't come with keyboards. So what you need is to be able to have your laptop operate as though it were the keyboard and monitor. And one way to do it is through the console connection. And then you simply bring up a console program, or you can do it through what's called secure shell over the network. Then you're not going through the console port, you're going across some type of network, or through Telnet. And these two basically are both the same in the sense that they cross over the network. This is recommended because it will encrypt the communications. This does not encrypt the communication, so therefore it's in plain text as it goes across the network, and if someone captures it, they can see your passwords and commands. So what we would do to be secure, if we are not directly connected to the switch or the router with a cable, then what we do is we open up a terminal emulation program, a secure shell program of some type, and connect across the network. So we have terminal emulation programs. They can connect directly or across the network. And these are a few of them: PuTTY, TerraTerm, secure CRT. So these are all programs that you can download to your computer and run them and connect to the computer, I mean to the router or switch. Now, when we're in Packet Tracer, we simply have to, we'll have a little tab we can click on, and it will be as though we are connected through the console port. And that's real nice as far as for learning. But of course, if you ever got out there in the real world, you'd have to learn that next couple steps of how to physically connect and make it work. Okay, so iOS navigation, in other words, how are we going to interact with this operating system? And there's a lot of things going on here. Don't worry if this sort of comes by in a big blur, because this is what we learn by practice. This is sort of, we're going to go out to the tennis court. I'm going to lob a ball over to you. You're going to hit it. Lob a ball, you're going to hit it. Lob a ball, and you're going to hit it. Eventually, you hit it, and you hit it, and you hit it, and go, oh, that's okay. Now I got it down. I'm hitting the ball. But for right now, it's going to be a little bit strange. Armando probably has experience with this. This would not be strange to him, but if the two of you have not interacted with Cisco devices, this makes no sense whatsoever right now, okay? Okay, so I will try and explain it as we go along, but just understand that we're going to see this, we'll actually interact with it next Thursday. Okay, so first of all, I have to be connected to the router either physically or across the network. One way or another, I'm connected to the router. I have my keyboard, got my monitor, and I'm now on that switch or router and working with the operating system. And when I first make that connection, what's going to happen is it's going to show me either a prompt, if it's the default, either a router or a switch, because I start in what's called the user exec mode. So this is sort of like, you know, if you went to a doctor's office, this is like being in the waiting room. You really can't do much. You can hear all the things going on back there, but you can't do much, right? So when the prompt looks like this, and you see this little greater than sign there, when a prompt looks like that, that means you're in the user exec mode and you have limited basic monitoring commands, okay? So you'll want to learn that, and you'll soon become very comfortable. You look at that, oh, okay, that's the name of the device, and this indicates that I'm in the user exec mode. If I'm going to do anything on the router, I have to move from that mode into the privileged exec mode. In other words, I have to now have stronger access. And we'll just assume for our purposes that basically it's like going from a user to logging on as admin, okay? If you get here, it's as though you logged onto your own computer at home as admin. You can do everything. To get from there to there, you have to have that capability, and it should be password protected. So that means that from here, you have to issue a command to go there, and it will prompt you for a password before letting you go from there to there. So privileged exec mode is the administration mode, essentially. Now, once we're in the privileged exec mode, we have that pound sign. We have different levels of operation. This is how Cisco set it out. There's different levels of operation, and that's what we have to deal with. We have the global configuration mode. So global configuration mode means that we're going to be able to configure things that apply to the entire router, not a specific interface. The router has interfaces so that information can come through it. But in the global configuration mode, we can do something like set the name of the router. For example, that's a global configuration command, setting the name for the router, okay? Then we have different lines. So we mentioned earlier, we're going to come in through SSH or Telnet, something like that. We have a line configuration mode. We can configure the passwords that would be applied to those lines. That's what they use the term line. It's actually just, you know, a place where a cable would connect. Then you have interfaces, Ethernet being one of your common interfaces. And if you're going to configure an Ethernet interface, you have to go into the interface configuration mode. And when you do, the prompt is going to look like this. The host name, which in this case is defaulting to switch, it's on a switch, or router if it's default there. Config-if, that tells you that you're in the interface configuration mode, but it doesn't tell you which interface. So you have to keep track of what you're doing. Otherwise, you might configure the wrong interface, and that could have consequences. Actually, could have disastrous.
I have a question.
Yes.
Which of the Cisco classes tutorials goes over this? I'd like to read it before Thursday.
Well, if you'll read this module and practice with Packet Tracer, you can do this with this module. You don't need a separate class for this. It would be only part of some other class, and it's mainly part of this class. So I'm not expecting that all this, like I said, is going to instantly make sense. I'm just giving you some words. You'll probably need to hear this a few times.
So is this, when you say this module, these slides?
Yes, it's well, see module 2 here. If you don't look up, this is Introduction to Networking, module 2. You
Okay,
can look through these slides and you can do the reading. And if you do the reading, you'll see that there'll be exercises as you do the reading. So I would, that's the homework assignment actually for this next week, is for you to read modules 1, 2, and 3. And what you can do is you're reading and doing the little exercises that they give you. They'll actually put you at a command line and you can practice with it. Okay.
also, I'm sure someone's done explanations on YouTube.
Well, there
So-
are explanations on YouTube. You can do that as well. I
Okay.
would try the class first, but if you just wanted to, the thing is, that would be, if you do an explanation on YouTube, you won't have the simulation unless you have a Packet Tracer up and running, and it shows you how to get into it. But if you actually go through the reading, the course materials reading, I believe you'll end up with them giving you a chance to key in things.
Okay, so let's do Intro to Networking modules 1, 2, and 3.
Yes, and just go through module 2 and read through it, and you should encounter labs. I'll check through that because I've just pulled the slides out. I didn't pull the reading out, but the reading is available to you. And if you have any problem accessing that, let me know. But you'll be able to do some practicing as you go through it.
Okay.
Okay. All right. And again, the reading is going to take you through this. How do I get from user exec, you see that little that greater than sign, to privilege exec, which is that I use the word enable. That's a command. Enable. So sometimes we call this the privilege exec mode, or we call it the enabled mode or enable mode. Anyhow, these are different ways that you'll be able to navigate, and it just takes practice. That's really what it is. It's nothing technically difficult. It's just a matter of learning. It's like learning a little bit of a foreign language, how to say yes, no, and help and that kind of stuff. Okay. And again, these are modes that you'll get into. We will demonstrate these next Thursday. Now, this is the command structure. So we're going to break this down. You'll see this in the reading, but let's look what I've got here. So I'm in the shell on my computer, and I have a prompt. The prompt says switch greater than sign. That's the host name. That tells me I'm in the user exec mode. And now I type a command. The command is ping. And that command has an argument that goes with it. Ping what? Ping that IP address. When I press enter, what's going to happen is that the switch will try and send a ping packets out to that address. Okay. I'm going to let the syntax, that's too confusing to try and work through right now. Let's just go on. And these are just examples. And this is why actually I'm not crazy about teaching with slides. I'm doing this because I want to have this, go through these. There are a lot of good information in them, but I prefer usually teaching by whiteboard. We'll probably switch over to that more next week. But again, here's an example. Ping IP address. Trace route, which is another command, IP address. Trace route is similar to ping, but it sends out different packets to determine what devices are alive between you and the destination. This is telling you about help. As you go through the reading, you'll see that you have what's called context-sensitive help. So you can put in a question mark anywhere, and it will tell you what are the options at that point. Okay. All right. What they're showing you here is a combination of things, but if we look at this, router is the host name, # means I'm in privileged exec mode. I type CON and then I press enter. Well, CON is not those 3 letters are not unique to a given command. So what it says, I can't figure, basically ambiguous command CON is telling you, I can't tell what you're trying to do, you know? So what you do is go CON question mark. What's possible? What are commands that start with CON? It says, oh, there's 2. One is configure and the other is connect. So then if I typed configure and put in a question mark, it would say, what would be my options then? Well, what they're jumping to is CONF as a set of letters is unique to the configure command. No other command starts CONF. So I don't have to type configure. I can just type CONF space, and then what would be next? Well, if I were to put a question mark there, terminal would be one of them. Nothing else would start with a T. So if I go config T, that would say configure from terminal. That would be what I'm doing. And again, with practice, this will start to make sense. You'll be using conf T all, as long as you're working on Cisco devices, this will become second nature. Okay, again, these are little shortcuts. These are things you'd want to know for the test. Right now, we don't need to know them, but we'll become familiar with them eventually. And again, these are some shortcuts and other things that we will learn about as we interact with the command line. So now let's look at, okay, so we're using this command line. And again, we sort of bumped into this. Well, what are we trying to do? Well, we're trying to configure our device. And we're trying to configure either a router or a switch. And in trying to do so, we have a number of different options, some of the basic things that we're going to do for a router or a switch. So let me ask, first of all, before we go further, Roger and Georgiana, this is not a trick question or anything else. It's just, do you know what is a router and what is a switch? Do you know could you tell me the distinction between the two? And if not, that's fine.
I have a router for my home internet.
Yes, you have one.
As far as a switch, I don't know.
Okay.
A router is a smart device, and a switch, from what I understand, the switch doesn't have the same capabilities as a router.
That's
But the
right.
switch.
Okay. So let me explain a little bit. Again, it would become easier to explain later on, but because we'll have more information that I can refer to. Right now, if I tried to explain it in great detail, you wouldn't understand all the components I was using. But basically, a router forwards packets based upon the destination IP address. Okay? And so if I send something out of my computer and I want to go to a website, let's say Microsoft's website, I have to, my computer will find out the IP address for the Microsoft website and put that into a packet. And eventually then routers along the way will each look at the destination IP address and determine where it goes next. This is pretty much what happens in the post office. So if I am going to mail a letter to somebody, what do I put in? I put in the destination address, correct? I would put in, so let's just look at that. If I put in a destination address, I'm going to send something to 111 Main Street, Los Angeles, California, okay? And I put that into the mailbox. I drop it off at the post office. Now, the local postman is going to want to know he's got this letter that's supposed to go to Los Angeles. And let's say that this postman is in Santa Cruz, okay? Now, what this postman is going to determine is what bag do I put it in that's going to eventually end up going, not the whole bag, but things within it will eventually be sorted out and end up going to Los Angeles, okay? So let's say, do you guys all live in the Santa Cruz area?
San Jose.
San Jose, okay.
SoCal.
You live in SoCal?
Sokol, next to Aptos.
You live in Aptos in SoCal.
No, yes,
I live in SoCal.
SoCal.
I live in SoCal.
Yeah.
Okay, so
We're
all
in
right,
Watsonville.
and you're in Watsonville. Okay,
Yeah.
So, well, let's say that we all go down to this. We all happen to want to mail a letter, and Roger happens to be over the hill visiting the beach, and he's got this letter, and so we happen to all go to the Santa Cruz post office, and we drop off this letter in the Santa Cruz post office that's going to Los Angeles. Now, do you think that there is a bag in the Santa Cruz post office for all letters going to Los Angeles? Or do you think that there is a bag in the Santa Cruz post office that's for all letters that are not local, right? Think about that. If Santa Cruz post office isn't going to have a bag for letters to Los Angeles, a bag for letters to San Francisco, a bag for letters to Sacramento, right? It's not going to have a bazillion different bags, right? It's going to have one big bag that says, this isn't local. And it's going to have some other bags. Oh, this goes to Capitola, this goes to SoCal, this goes to Aptos, this goes to Watsonville, right? So down there at the post office, what does the post staff person look at? They're going to look at the destination city-state combination, right? And they're going to determine whether it goes out of the local post office or it's in the Santa Cruz area. That's all they're really trying to determine. And if it's local, then they'll try and find the local bag. Does this make sense so far?
Yes.
Okay, so we would say, does that person, that staff person there at the Santa Cruz post office, do they even care what street? It was 111 Main Street. Would they care that it's 111 Main Street or 111 Second Street? They're not going to even look at that, are they? Right? So what they're going to look at is only the location of the destination, the general location. That's what a router would do. It's going to look at the information in the packet that tells it what is the general destination, and it's going to figure out what interface it goes out next. Okay, or you might say at the Santa Cruz post office, that guy's going to figure out which bag does it go into, which truck is it going to end up in, leaving the Santa Cruz post office. Is it going to be a truck that goes over to San Jose for the San Jose, because all the mail that's not for Santa Cruz area is going to go over to San Jose next for processing. So you might say that it's either going to go over Highway 17 or it's going to go out to SoCal or Aptos or Watsonville or whatever would be local, or Boulder Creek, whatever the local post offices would be. But so that's what a router is going to do. It's going to say, does it go out to the internet somewhere? That's its first decision. And it's looking at the location. All right. So routers, and this is, I know it sounds very simple, but it's exactly what a router does. A router looks at the destination IP address to determine the general location of that. And if it is remote, it then determines where it goes next from that router, just like our post office person, he looks at the general location, Los Angeles, California. Of course, they probably look at zip code, and if they're processed by machine, they got it so it looks at zip code and all that. But same concept. They're looking at location information, general location information, and then where does it go next? That's what a router does. Okay? So now, that little envelope that we put in the Santa Cruz post office gets sent up to San Jose. In San Jose, it's similar thing is going to take place. There's going to be bags for, and it's a bigger station. There are going to be bags that are saying this stuff goes into Los Angeles, to the Los Angeles central office down there. It's somewhere in Southern California. Okay? And bingo. Now it's taken down to to Southern California. And again, the San Jose post office was a router. It looked at the ultimate destination of the area. It did not care again whether it was Main Street or Second Street or anything like that. It gets down to LA. In LA now they're going to care. What is the zip code? Oh, it goes to West LA actually, or it goes to this part of LA with this zip code 92102 or whatever the heck it is. So it says, oh, that's going to go in this little bag that goes out to that little office that's out there in West LA, for example. Now, when the postman gets this for his route, does the postman look, he's got everything for Los Angeles, California, 941 or 92103 or whatever the heck it is. All the letters say that on the bottom. So what does the postman himself look at next? What does he care about? He cares about the street address, right? What street is it on? Okay, now we're narrowing things down. Now we're going to act, starting to act more like a switch. And so now when the postman actually has all his letters ready to go, the postman is acting like a switch because now he cares what goes on Main Street. He needs to know what. Is it 111 Main Street? Is it 115 Main Street? He's looking at a different part of the address. That's the difference between a router and a switch. A switch is looking at very specific information as to what device this goes to on the local network. In other words, imagine the postman sitting there at the corner and he's got all the letters for Main Street. What does he care about? He wants to know if it's 111, 115, 117, right? He's looking at the number. When you get to a switch, the switch is looking at that portion of the information in the packet that says, what device does it go to? Or what on this street, what house does it go to on this street? And that's the difference between a router and a switch. They're making a forwarding decision, a delivery decision based upon different parts of the packet or different address information. Okay, so you might say a switch looks at the street number and a router looks at the city. Okay, just for
So if someone's sending a packet, is it possible to go through, say, 10 routers,
yes.
but one switch? That's a good ratio?
Oh, I wouldn't say that it's a good ratio. It probably would go through more switches than that because the way switches are deployed, as we'll see. But what you'll see is that, well, so for example, let's say you've got a guy down at the central post office, right? And he's got letters that go out to the post office in West Los Angeles, okay? The driver of that particular vehicle is going to be going through streets trying to get to a particular street and a particular address where the post office is, correct?
Mm-hmm.
Okay, so that driver is actually looking at specific street information and address information. So what happens is when it goes from one router to the next, it may go through switches in between routers, just so it goes from the one router to the next correct router. That's all. But don't worry about that right now. Yes, it could go through multiple switches. In fact, it most likely will. And as you really get an understanding of how this all works, you'll see that a lot of things get blurred. But yes, it will go through multiple switches. As it goes from router to router, it's going to end up going through switches along the way as well. Okay.
I use the Amazon package delivery thing as fun to look at when I order something from, say, New York, or all the hops it goes through before it finally makes it to California.
Yep. And each of those hops is a router.
Okay.
Okay. So with that concept in mind, we can then look at our device configuration and say, well, this would also apply to configuring a post office. You might say at a post office, we only let certain letters come in here. You know, if someone tries to send a letter to our post office, we don't take it because it's not supposed to come here. That would be filtering, right? So anyway, we'll see that as we go through this. Okay, so what we're going to do is start to configure our, in this case, switch. To configure it on a global configuration mode, we go configure terminal, which config T would get us there as well. And now this shows us here, I wish I could highlight that, but it shows me the switch name. I'm in the global configuration mode, and I'm also in the privileged exec mode as well. So I'm in the privileged exec mode, global configuration. And now I'm going to issue a command. The command is host name. And after that, I type in what is the host name that I want to apply to this switch. It's now named switch. I'm going to now name it SW-floor-1. I press enter, and look what happens. Instantly, the host name changes. Okay? This is important to understand in the Cisco environment. When I type this command right there, it instantly took effect. What we're going to see, there is a what we call a running configuration. In other words, there's an active configuration on the device. When I enter a command, I change the active configuration. This has implications down the road when we are doing things, because it means that we can blow up our situation if we're not careful, because we are actively, it would be like saying, I'm going to tune my car as we're driving down the freeway. Boy, I better get that right, right? You know, because all of a sudden things may stop working. That's exactly what can happen on a Cisco device. You are changing things as it's running, okay? You want to get it right. Okay. So one of the things that we're going to do, we've just set the host name for the switch. Another thing we might want to do is password protect the switch. And here's some guidelines. We won't worry about that. Those are, yes, we understand we got to be careful and do that. Okay. So what we're going to do is we're going to configure access to this switch, access through the console port. The command to get into the right mode is line console 0. That puts us into the mode of configuring this line. And now we can set the password for access through the console port. The command sets password Cisco. But that command is not enough. We also have to say login. In other words, we're telling the switch, here's the password, and require people, the login says people have to log in and they have to give that password. Those two commands together mean that if someone is going to access this device through the console port, they have to issue that password when they go to log in, and they will be prompted to log in. We then type end, and that simply bumps us back up to the very top privilege exec mode. That's all this does. It just pushes us back up in levels. Okay? Any questions on that? Very simple. You'll want to do this on your Cisco devices with Packet Tracer, and then pretty soon it gets comfortable. You will see yourself navigating the command line, it'll get comfortable, and won't have a problem, okay? Now, again, configure terminal. I started at the top here, I'm up there, and I type configure terminal, and I'm gonna set the password for getting into the privileged exec mode. And to get into the privileged exec mode, you would type enable, but when someone types enable, I wanna make sure that they are going to have to give a password. And I want that password encrypted on the device. I don't want the password stored on the device in plain text. The command is enable secret, and then I give the password. Password. In this case, the password is class. Press enter, and now it's set. I type exit, and here. Now, I am already in the privileged exec mode, so I just set the password, but I'm not being prompted for it because I'm already in that mode. If I were to exit out of this mode and then try and come back in, I would have to give it that password to get back into the mode I'm in right now. Okay? I know this is really exciting when you've never configured a Cisco device before, never touched one. It's like, oh my God, this is, it's like how to change the spark plugs and you've never seen a car before. It's like, well, who cares, But eventually, the joy of this will become evident, And to configure access through Telnet, for reasons which we won't go right now, the command is line VTY 0 space 15, password Cisco, login and end. I will explain the nuances of that line VTY, but that's the command. And this is part of what you have to do in Cisco, is you learn what is the right command. You don't, ask Cisco, you don't call up Cisco and say, why did you make the command that stupid thing, You should have made it this, because you sometimes wonder what were you thinking when you made that the command, okay? All right. Now, understand, again, the way they present things, to me, the order, it makes it difficult sometimes to get all this under your belt, but we will have practice with it, so we will. When you enter passwords in, normally, they are not stored encrypted unless you use the enable secret command, okay? If you use the enable secret command, that automatically encrypts. But when we enter those other passwords, those passwords are not stored encrypted. And so if somebody that sees gets a hold of our router configuration, which they could possibly do, they can see our passwords. So if we want those encrypted, we use the command service password -encryption and enter. And now we type exit, and or exit would have done the same thing. It just moves us back up one level. And now we'll see why we're doing this, moving up and down these levels, and you'll get comfortable with doing that, okay? And, well, let's not worry about banners right now. That's another one. Won't worry about that. Okay, so this is very important for a number of reasons. Saving your configurations. And the first reason why it's important is that your configuration that you are building as you go along is an active configuration, and it is stored in memory, in random access memory, or RAM. That RAM keeps anything in it unless it loses power. So if you made changes to your configuration and then the power went out, you would have lost all your changes. And that's not a good thing. So what you'd want to do is save your configurations in case the power goes out. The other thing is that if you're taking the Cisco CCNA exam, whenever you're making changes as part of your exam answers, you want to save it, because they don't look at what you configured, they look at the configuration that you save. So Armando, you want to save your configurations as you build them when you are taking the exam, okay? I've had people in my classes that did not pass the exam simply because they forgot to save the configuration. That was all they had to do, is save the configuration. They would have passed the exam. Okay, so there are actually two configuration locations. There's the running configuration, the active configuration. And then there's a configuration that's stored in what's called NVRAM, non-volatile RAM. If the power goes out or you turn the device off, what is in NVRAM is not lost. It is stored, it's battery backed up. Okay, so what I'm doing when I'm configuring the router, I'm normally configuring the running configuration. What I want to do is save it to a place that is safe in case the router loses power, and that's the startup config. So the way I do that is with a very simple command. But first, they're just letting us see a command to see those two different configurations. If I say show startup config, it shows me the configuration that is stored in NVRAM. I show running config, it shows me the active configuration. So I could do show run or show start, and I look at those two different configurations. Okay, or they might be the same. If I've just saved the configuration, they're both the same. Let's go here. If I do not want to save my configurations, I could simply reload the router, and then what is ever in NVRAM will be what I end up with. Okay. If I don't like what's in NVRAM, I can erase it. Again, we'll get to those details later, but let me get on to here. Okay. Way too much information. Okay. Well, they're not giving me the actual command, but it's very simple. Copy the command to save my running configuration to my startup configuration is copy run start. There is a shorter version, which I will show you Thursday, but for right now, you want to know copy run start is what you would issue whenever you want to save your configuration. Okay. Okay, now we're looking at IP addressing. Again, they're jumping the gun on this. They're assuming that you would even understand IP addressing. So let's talk just a little bit about IP addressing. First of all, how many of you are well familiar? Armando, I think you probably are well familiar with IP addressing or somewhat, right?
Yeah,
Okay,
pretty familiar.
pretty familiar. Okay. Georgiana, have you ever studied IP addressing and subnetting and all that?
A little bit.
A little bit, okay. So I'll ask some questions. You guys can answer them, and we'll figure out where everybody really sort of is, because we will eventually get back to IP addressing, but I want to make sure we have some rudimentary understanding. Okay, and Roger, are you familiar with IP addressing?
I may know it as another term.
Okay, all right. Well.
I'll see you after you start explaining it.
Okay, so let's try this. What we see, let's go down here to the next. What we see, when we look over here, we see an IP, you've all seen IP addresses before. And this is, you're seeing four numbers right here, 192.168, 1.10. Is that what everybody sees there in that box? Yeah. Okay. So here's what's going on. Each of those numbers actually represents 8 bits binary. Okay, and I'll show you how that is figured out. But for right now, just understand that each of those numbers represents 8 binary bits. And we have 4 numbers, so we have a total of 32 binary bits. Okay? So I've got 8 plus 8 plus 8 plus 8. That's what's represented. And I'll make this, simple for you. Eventually, it'll be like, oh, okay. Even though it'll always be a challenge if you're trying to work it down to bits and all that. But okay, so I have this represents 32 bits. Well, an IP address has 2 parts to it. One part is the location part, and the other part is the actual address of the device itself. So there's actually 2 components there. Okay. Now, this would be like if I were to look at a house address, and if I said it's on 111 Main Street, Well, Main Street is the network that it's on, but 111 is the actual device, is the actual endpoint, right?
Hmm.
So for us, if I told you 111 Main Street, you would say, oh, I know what the 111 is the building, and Main Street is the street. Everybody would know that, right? The reason why you'd know that is because that's our protocol. That's the way we address things. Well, if I instead just wrote a bunch of numbers, let's say I wrote 1, 2, 3, 4, 5, 6, 5, 2. Okay, so you'd say, well, that's a bunch of numbers. What does that tell me? Oh, well, that's 1, 2, 3, 4, 1, 2, 3, 4 on 52nd Street. Gee, you couldn't figure that out? Well, no, you couldn't figure it out. There would be no way for you to know if I just gave you a bunch of numbers, right? Well, that's what we have here. We have a little bit of a problem. We got 192, 168, 1.10, and there's actually two things that are encompassed in that address. One is what network is it on? And then what host is this? Well, we're going to keep it real simple right now. Down below, we have what's called a mask. And the mask, where the mask ends, that's where the network portion ends. So where the 255s end, that's where the network portion ends for now. It's going to get a little bit more complicated than that. We'll see. But basically, if I said, oh, wait, so where I have 255, 255, 255, that means that up above, those three are the network. And where I have the 0, that means that that up there is the host. So now I know from this address right here that this host here is on the 192.168.1 network, and it is host number 10. Okay? So for now, just accept that simplistic explanation. It is accurate, but it is not complete. If we always address things like this, it would be all we would need. But we have some wrinkles that we have that Cisco loves to test you on. So, bingo, that's what we have right there. This is the street, and that's the address of the device. So let's say I've got 35 computers on this network. They'll all have the same 192.168.1 part, but they'll all have a different number here. Just like on Main Street, you have all of them are something, something, something Main Street, but every one of them has a different building number or house number, right? Okay. And down here we have what's called a default gateway. That basically says if I'm going to send something that's going to leave this street, that's where I send it to next. We'll understand that eventually later. This is how you configure a Windows device. That's not how you configure a Cisco device, but that's something you have to know for a CCNA exam, is how to configure a Windows device. And we'll get into that in greater detail. Not much. I mean, this is basically the window that you have to understand, okay? Now, we can obtain the address configuration automatically, and we just see here, we've said obtain this information automatically. Bingo, now I'm done with my configuration. Again, this is on a Windows device. We'll understand how that works as well. Okay, and this is really, I laugh because the people that put these things together jump around and introduce all of a sudden a whole nother concept without any background. So I'm going to have you guys ignore that for now. Eventually, you'll understand this, okay? But that would it'll cause more confusion right now than anything else, because we don't have enough background information to understand why we're doing this and why it works that way. So just ignore that one, okay? All right. So that takes us through, we've gone through modules 1 and 2. I think that would be good for tonight. Are there any questions about what we've covered so far? And I would hope that you'll all stay on board and give this class a chance. asking questions as you go. Do the reading in the meantime, and then if you have questions during the reading, bring those questions to class next week. And what I'll be doing more next week is working with a whiteboard in our Zoom session here and trying to make this simpler, break it down into simpler terms and not sort of have it all come rushing at you at one time. Okay, so we'll do that next week. I have some configurations that I use on whiteboards that break this down and make things pretty easy. Okay.
So one more time, where are the modules under Network Academy when we log in?
Yes, you modules 1, 2, and 3.
Okay.
Yeah, we've covered the slides for 1 and 2, but just read through it again. I'm not saying it's all gonna, stick, but just go ahead and read through it, and then we'll start with module 3 next week. And we will work with download and install Cisco Packet Tracer, have that ready to go, and also be ready to, be hands-on while we're doing this. I'll be, as I say, doing some whiteboard. I will send out what are called scenarios, and that means I'll have little devices put into a topology, and then we can click on those devices and we can make them work, and you'll actually get a chance to interact with devices. Some very simple scenarios so that and I can show you even how to build a scenario, but we'll have a very simple scenarios that you work with a packet tracer. Pretty soon, once you get to a certain point, if you've got packet tracer and resource materials, there's so much you can teach yourself through exploration. At one point, about, I guess it was a little over 20 years ago, I don't know if you folks are familiar with the Cisco certification of CCIE. I don't know if you've heard of that one. Okay.
Nope.
Okay, so there's 3 levels of certifications. There's CCNA, CCNP, which is Cisco Certified Network Professional, and then there's Cisco Certified Internet Networking Expert. That's CCIE. And the CCIE certification is the highest you can obtain. Well, when I came to begin working with Cabrillo, I was already had my certifications for CCNA and CCNP, and I'd already passed the written CCIE. And I was going to take the lab, the in-person lab, CCIE, and I began to start doing preparation for it. And so I would come into the labs that you have there. Of course, you have access to those labs at Cabrillo as well. They're physical routers, and I would plug cables in and sit down, and I would try all these different configurations. And I was able to teach myself a lot. That's basically how you prepare for something like that, is you sit down in a lab environment. You'd have to go beyond this, the packet tracer simulator, because you'll need to know more than what it would do. But you basically sit down with routers and switches and you configure them and you try and make them work, and you do troubleshooting and Well, you folks are at a point now, you have a tool, this packet tracer, that will let you learn a tremendous amount without having to go in and do a lot of cable switching and turning things on and off and all that. It's a wonderful tool, and we'll get into that next Thursday. So, okay. And if you decide to drop the course, please just let me know so that I can anticipate, the census for the administration. But I hope you all stay in it, and we'll make this work for everybody.
Yeah, I just hope I get this remote. I got a job actually. I just hope I will continue with the job that is remote and not with the one in person. It just depends on the checks they do on me. Right, so let's see. I hope I get, because if I get the remote job, it's going to be very easy to attend.
Oh, good. Well, good luck with that.
I got the offer, just I told you just now, the last steps.
Oh, good. Well, good luck with your career is obviously your first priority there.
Yeah, but
Okay.
yeah, let's see what's going to happen. But yeah, I plan to stay.
Okay. Look forward to seeing you next Thursday then.
Yeah.
Sorry, so when's the next meeting?
Thursday at 6 o'clock.
Okay, for sure.
And if you have questions, you want to meet with me during office hours, I can meet before that. So just send me an email and say, I'd like to meet with you like at 5 o'clock and go over some things, and we can do that.
Yeah, perfect.
And the link is the same link all the time?
Yes, it'll be the same link.
The same link.
Yeah.
Thank you.
Same time, same link, and we'll see you soon. We'll pick up at 3 and I'll have Packet Tracer going and do some whiteboard stuff and yeah, help you understand all these basic things. Once it comes together, it's not too bad.
Yeah.
Okay.
So I can run the CLI from Packet Tracer?
Yes, in Packet Tracer you can.
Okay, I guess it's scriptable.
Well, I wouldn't worry about scripting it right now.
No, I'm just curious because
Yes, yeah, to a degree there's scripting, but what you're more concerned with for at this level is to understand the basic commands, because of course you can't script anything until you know what commands you want to script.
Yeah. I'm just thinking that if someone had to set up 100 of these, they would not want to use the UI.
Well, no, but here's what you do actually. What you would do, well, let's say you had 100 of these to set up with certain things that all of them would have in common, okay? What you would do is you would put all the commands that we just were going, well, whatever commands you would want, you put them into a text file. And then you simply paste the text file into the router and they automatically execute, just like a script.
Okay,
Okay. So actually, it can be very easily done if you understand the command line commands, just as they're written, just as they're entered. In fact, what you would want is a backup of your configurations in that text format for exactly that reason. So if a router had to be replaced, you could bring the new one in and just put the configuration back in instantly.
are you gonna send us like a PK, what's it called, PKA file for Thursday's lecture?
Right, yes. There are files that have scenario that are called Packet Tracer scenario files that we'll be working with. And I have a number of them that I will send out to you that are simpler than what you will work with in the packet or in the course. And the reason is that I like, again, to focus on certain little configurations rather than have something involved for now. Later, I'm going to send out a scenario that's going to be quite complex, but by that time, we'll be ready for it.
Sounds good.
Okay.
I'm gonna try my best to stay in the class.
I'm sorry, what was that?
I'm gonna try my best is,
Oh, okay, well, that's great. Well, I hope it works for you.
okay,
Thank you. All right, well, we'll see you folks next Thursday.
okay, bye-bye.
Bye. Thank you.
Thank you.
Bye, thanks.
Bye-bye.